Hello students, today let us learn types of quadrilaterals. Before this we have studied all the basic terms regarding a quadrilateral. In this video we are going to learn various types of quadrilateral and their properties. So we'll start with the first type of quadrilateral, which is a parallelogram. Let's have a diagram. So this is a quadrilateral given which is named as quadrilateral ABCD. Now for this one, as we can observe, the pair of opposite sides of this quadrilateral are parallel to each other. That is, AB is parallel to side CD and AD is parallel to side BC. If such a quadrilateral is there, it is called as a parallelogram. So from that we have the definition. A quadrilateral having opposite sides parallel is called as a parallelogram. Now let's have its properties. The first property is the opposite angles of parallelogram are congruent. So if you consider this quadrilateral ABCD, then angle A and angle C, this is the pair of opposite angles. So they must be congruent. In the same way, there is another pair of opposite angles, it is angle B and angle D. So they must be also congruent as they are opposite angles. So this is the first property of a parallelogram, that opposite angles of a parallelogram are congruent. The next property is opposite sides of a parallelogram are also congruent. So if you consider here side AB, its opposite side is side DC. So these two sides must be congruent, and another pair of opposite sides is side AD and side BC. So these two sides are also congruent, which means that opposite sides of a parallelogram are congruent. Now the next property is about the diagonals of a parallelogram. So if we join here the opposite vertices of this quadrilateral, that is A and C, we get here a diagonal AC. In the same way, there is another diagonal BD is there, and the property of its diagonals is that diagonals of a parallelogram bisect each other. That means, suppose these diagonals intersect each other at point O, then due to diagonal AC, diagonal BD is divided into two parts, that is BO and OD. So which is a congruent. That means diagonal AC made two equal parts of diagonal BD. In the same way, diagonal BD also make two equal parts of diagonal AC. That means AO is congruent with OC. So this is the property of a diagonals of a parallelogram, that diagonals of a parallelogram bisect each other. Next type of quadrilateral is a rectangle. So let us have the diagram here, which is a quadrilateral PQRS is given. Now as we can observe here, all the angles of this quadrilateral are right angles. That's why we can define rectangle as, if all angles of a quadrilateral are right angles, then it is called as a rectangle. So for this quadrilateral PQRS, all the four angles are right angles. That's why this quadrilateral PQRS is called as a rectangle. Now let us have its properties. The first property is opposite sides of a rectangle are congruent. So it is the same property as the parallelogram. So here opposite sides of this quadrilateral are PQ and SR. So these two sides must be congruent. In the same way, another pair of opposite sides is PS and QR. So they are also congruent. So this is the first property of a rectangle. Opposite sides of a rectangle are congruent. The next property is diagonals of a rectangle are congruent. If we draw the diagonals PR and diagonal QS, they are congruent for the rectangle. This diagonal PR is congruent to diagonal QS. This diagonal PR is equal to diagonal QS. The next property of a rectangle is that diagonals of a rectangle bisect each other. So it is also the same property as a parallelogram. Diagonal PR and diagonal QS bisect each other. Now let us have the next type of a quadrilateral, that's the square. So this is the diagram of square LMNO. Now we can define a square as, if all sides and all angles of a quadrilateral are congruent, then it is called as a square. So for this quadrilateral LMNO, if all the four angles are equal, that means they must be of measure 90 degree. They can be of equal measures. So if all the four angles are to be congruent, then measure of each angle must be 90 degree. That means for this quadrilateral, all the four angles must be right angles, so that all the four angles are congruent. And for this quadrilateral, if all the four sides are also congruent, that is LM is congruent to MN, which is congruent to ON, which is congruent to LO. If it is so, then we say that quadrilateral LMNO is a square. And here LN and OM are the diagonals of a square. We have the first property, diagonals of a square are congruent. So here diagonal LN is congruent to diagonal MO. The second property is same as the rectangle, that is diagonals of a square bisect each other. And the third property is diagonals of square perpendicular to each other. That means if these two diagonals intersect each other at point P, then at point P the angle formed is a right angle. So this is the property that diagonals of a square are perpendicular to each other. And the next property is diagonals bisect opposite angles. So this is the another property for a square, that the diagonal of this square LMNO bisect opposite angles. So here diagonal LN is there, which bisects the opposite angles. So the opposite angles are angle L and angle N. So as Ln is a diagonal, angle OLN is equal to angle MLN, as this is the diagonal which bisects the opposite angles. Here the opposite angle of angle L is angle N. So diagonal Ln also bisect angle N. That means angle ONL must be congruent to angle MNL. In this way, the next property holds that diagonals of a square bisect opposite angles. The same property is there for the other diagonal also, that is diagonal OM also bisects the opposite angles. The next type of quadrilateral is a rhombus. Suppose there is one quadrilateral given, we'll name it as quadrilateral X, Y, Z, W. And for this quadrilateral, if all sides of a quadrilateral are of equal length, then it is called as a rhombus. So for this quadrilateral X, Y, Z, W, if side XY is congruent to side YZ, which is congruent to side WZ, and which is congruent to side XW, then we say that quadrilateral XYZW is a rhombus. And the properties of rhombus are there. Opposite angles of a rhombus are congruent. So this is the first property. Then the second property is about diagonals. Diagonals of a rhombus bisect opposite angles of a rhombus. So this is the same property as that of square. So here also diagonal XZ and diagonal YZ bisect the opposite angles. The third property is again about the diagonals of a rhombus. Diagonals bisect each other and they are perpendicular to each other. That means diagonals of a rhombus are perpendicular bisectors of each other. So for this diagram, suppose these diagonals XZ and YW intersect at point O, then in that case XO is congruent to OZ and OW is congruent to OY, as these diagonals bisect each other and they are perpendicular to each other also. That means the angle between them is right angle. So this is the property of a rhombus, that is diagonals of a rhombus bisect each other and they are perpendicular to each other. The next type of a quadrilateral is a trapezium. Watch this quadrilateral. For this quadrilateral, only one pair of opposite sides is parallel. That's why it is called as a trapezium. We can define it as, if only one pair of opposite sides of quadrilateral is parallel, then it is called as a trapezium. So in this diagram, quadrilateral PQRS is a trapezium as side PQ is parallel to side SR. So this is the only parallel side for this quadrilateral, and the another pair PS and QR, these are not parallel to each other. That's why this quadrilateral is called as a trapezium. Now here one property of trapezium is there. In trapezium, out of 4 pairs of adjacent angles, 2 are supplementary. As we can observe here, angle P and angle S. So this is the pair of adjacent angles, and as we have studied that PQ is parallel to SR. That's why these two angles are interior angles, and we know that interior angles, if two parallel lines are intersected by a transversal, then the interior angles so formed are supplementary. So here the first pair of adjacent angles is angle P and angle S. That's why we can write here angle P plus angle S is equal to 180 degree, and there is another pair of adjacent angles, that is angle Q and angle R. That's why angle Q plus angle R is also equal to 180 degree. So this is the property of a trapezium. So there is another type of quadrilateral which is called as a kite. So this type of quadrilateral looks like kite. That's why it's named as a kite. We can define kite as if one diagonal is a perpendicular bisector of the other diagonal for any quadrilateral, then that quadrilateral is called as a kite. Now we have the first property of a kite is that two pairs of adjacent sides of kite are congruent. So here adjacent sides are AB and AD. So here AB is congruent to AD. There is another pair of adjacent sides, that is BC and DC. This is also congruent. So these two pairs of adjacent sides are congruent. We have another property of a kite is that one pair of opposite angles is also congruent, and we have defined a kite as if one diagonal is perpendicular bisector of the other, then the quadrilateral is called as a kite. So suppose here diagonal AC is the perpendicular bisector of diagonal BD, then in that case we have here the angle between them is right angle, and these two smaller segments are congruent. Then we say that diagonal AC is the perpendicular bisector of diagonal BD. So this quadrilateral is called as a kite. So these are the some types of quadrilaterals and its properties. Hope you understand this concept. Thanks for watching.